2-2 applications of equations. Keep up with me. Two applications of equations. Applications of equations. What does that even mean? Applications of equations. What?
Like setting up equation.
Using it. If you apply something that you know, right? That means you're going to use it. You're applying it. So we're going to apply these equations to real life situations. She said it. Translating phrases. Okay? The product of a number and 8. The product of a number and 8. Well, keyword product, right? What does product mean? Multiply. What is a number? What do I use for that?
X.
X. I have x times 8 or 8x. The sum of 6 in a number, comma, multiplied by 9. So I have the sum. What does sum mean? Add of what? 6 in a number, which is, that's my variable.
I'm not that funny.
The sum of 6 in a number multiplied by 9. So let me ask you a question. Which way is right? Top one? Bottom one? How do I know? What's that? Bottom one, why? There's one reason why. It's okay. Got it. Okay.
It's the sum of it's 6 first and then it's multiplied.
If I would take away one thing, it would be the top one. But because there's one thing there, it's the bottom one. What? You were paying attention to what I saw. I said, comma, and I read the problem. Okay? If I say the sum of 6 in a number and take away the comma, multiplied by 9, then it's the top one. But because of that comma, it's the bottom one. Okay? Practice. The product of 5 and a number decreased by 8 is 100. Now, here I have some more commas. Okay? When you see commas, a lot of times what you can think of is parentheses. Okay? So I have the product. What does product mean? Multiply. So the product of 5, okay, and that comma, a number decreased by 8.
X minus 8.
X minus 8 is 100. What is?
Equals.
Equals.
So product just makes
Product means multiply. Yes. Do you remember back in chapter 1, section 1, the first chapter, the first day? Remember all those keywords we wrote down? Okay, this is where those come in handy. Remember I told you when we solve word problems, you're going to want those? This would be a good time to get that out. The product of 5 in a number, did I just do that one?
Yeah. Yeah.
Like a duplicate?
No.
The comma's out. So what's this one? The product of 5 in a number, comma, decreased by 8.
5x minus
Aha, 5x minus 8
equals.
100. That's why I did that. You see the difference? Good. We're not going to go through the steps again, but we're just going to do some examples. A mattress for a single bed is on sale for $200, which is 4/5 of its original price. Find the original price. Okay? This one's not too bad. So I know that I'm going to pay a total of $200. Okay? That's something I need to know. 4/5 of its original price. Who can remember what does of mean? Multiply. So I have 4/5 times the original price. Do I know the original price? That's the sale price. 200 is the sale price. X, right? I don't know the original price, but I know 4/5 of that original price is going to give me $200, which is that sale price. Now, how do I solve this one?
Multiply by 4.
Yeah, multiply both sides by 5/4. Okay, if I can fit it in here. Multiply by 5/4. These are going to cancel. Left with x. Put 200 over 1. What's my cross reduce here?
1,000 over 4. No.
I want to cross reduce 204 first. The way my multiplication is.
50.
Yeah, 50 and 1. Now I have 50 times 5.
250.
So what was my original price? I'm going to abbreviate. The original price was $150. All right, let's move on. Another one. Now this one's a little bit difficult. Okay, this is as tough as they're going to get. The natural resources at BCC ordered trees. Some of the trees were elms. That's not right, is it? It's elm. Some of the trees were elm, costing $17 each, while the rest of the trees were maple at $11 each. The total cost of the trees was $375. Find the number of elm and the number of maple trees. Okay? Well, what do I know, first of all? I know I have 27 trees. Okay? I know that they cost $17 each. Well, here's the best way that I have found to solve a problem that looks like this. Okay? Make a box, figure out what you know. Okay? What do I know?
It's 27 trees.
Okay, 27 trees total, right?
Yep.
Well, number of trees total, 27. What else?
The cost of the trees are
Cost of the tree. What's the cost of an elm tree?
$17.
What's the cost of a maple tree?
11.
11. Okay. Do I know anything else in this box? Do I know the total cost of the
The
elm?
total of the
cost
trees.
Yeah, total cost of all the trees is what?
$375.
$375. Now, I'm missing how many trees I bought of each one. I know I bought a total of 27, but I don't know how many elm and how many maple I bought. So what would be a good start? How many elm trees did I buy?
Divide.
Okay, let's say I bought X elm trees. Now, how many maple trees did I buy? If I bought X elm trees, how many maple trees did I buy?
Okay.
Okay, you could make another variable. You said A, right? But then I have two variables and I only have one equation. How can I represent maple trees? Well, let me put it this way. If let's say that X stands for 13 or for 12 or whatever, how would you find how many maple trees you have? If I told you, okay, I had 12 or I had 10 elm trees, how many maple trees would I have? 27, yeah, I would have 27 minus 10. So if you take this 27 and you subtract out how many elm trees you bought, doesn't that give you how many maple trees you have?
Yeah.
Yeah. So now I'm still using X, so I still have one equation and one unknown. Okay, when I make my equation. So how do I find the total cost of the elm trees? How would I find it? 17 times X, and total cost of the maple trees is 11 times 27 minus X. The number times how much they cost. Now I need to write an equation. Anybody want to give it a shot? If the total cost of the elm trees was 17X, the total cost of the maple trees was 11 times the quantity 27 minus X,
Would it be 11?
and the total cost of 375
11 equals 370.
Okay, 11 times 27 minus X
Equals.
not yet.
Plus 17.
There it is. Total cost of the elm plus the total cost of the maple is $375.
I do it on the board.
No. We still have another one to do. 27. I think it's 295, all right?
That's
297. So I have 297 minus 11x plus 17x equals 375 because I distributed the 11. Combine my terms, negative 11x plus 17x, 6x plus 297 equals 375.
minus 297.
Gives me what?
78.
78 divided by 6. 13. What does 13 stand for?
Elm trees, 13
Yep,
elm
the number of elm trees. So if I had 13 elm trees, how many maple trees do I have?
40.
27 minus 13. There it is.
Ooh.
You could go outside and count the trees, but this is so much more fun.
She's like, why couldn't you just go catch?
So much more fun doing it this way. Michael Kern, I need to change that name. He was last year. Who should I change it to?
Josh Hillier.
Josh Hilliard.
No, it should be Wiesenberg.
No.
Being Zane Bercher.
And I called it first. Wait,
I didn't say anything.
Has Kayla has $15,000 to invest. Let's not use Kayla.
Josh. Zane
Zane
Hillier.
Is that right?
Or Josh Berger.
Okay. Zane Bercher has $15,000 to invest. He places a portion of the funds in a passbook account, $3,000 more than twice this amount in a retirement account. How much do you put in a passbook account and how much do you put in a retirement account? Could that possibly be a situation? What?
Can you put the?
No. I'm recording this. Aren't I?
Yeah.
I forgot that I was recording. Zane Bercher has $15,000 to invest. He places a portion of the funds in a passbook account, $3,000 more than twice this amount in a retirement account. How much is put into the passbook account? How much is placed in the retirement account? This could actually be a real situation with anybody in here, right? You have $15,000. Okay, you got it from mom, dad, whatever. Graduation present, maybe not quite that much. Okay. How much do you want to put in your checking account? How much do you want to put in your retirement account? Okay. Those of you who start a retirement account at this age are very, very smart because that's you're well on your way to become a millionaire. Okay. Now, what do I know? Passbook's checking account. Checking account. What's that? Yeah, 15 grand total. I know something's going to equal $15,000, right? That's how much I have. Because if I take the amount in the passbook account and add the amount in the retirement account, I'm going to get 15 grand. Well, what do I know about the passbook account? Do I know how much I put in the passbook account or the checking account? So that would be X. Okay? Do I know how much I want to put in the retirement account? No, but do I make it a new variable or can I write the retirement account in terms of X? How? Well, look at what it says.
$3,000 more.
$3,000 more than. What does that mean? What's that? Addition. Okay, so I'm going to take $3,000 and add it to what?
To
2x. Twice the amount in the passbook account, or twice this amount, which was the passbook account. So $3,000 times plus 2x. So I have x plus $3,000 plus 2x. And all that is $15,000. Now I just solve for x. What's that? It would be 4,000. 4,000 would be what? What's that? What does $4,000 stand for?
How much you put in
Yeah. The passbook account. So, to answer the first question, how much was put in the passbook account? You can put PA equals $4,000. So how much was put then in the retirement account? How would I find it?
11,000.
How'd you find that?
Subtract 4,000 from 15,000.
Yeah, you can take 15,000, subtract 4,000, or you can plug it into this part of the equation. You're gonna get $11,000 either way. 15,000 minus 4,000 is gonna give you 11,000. Because you have $15,000 total and $4,000 in the checking account. $11,000 in your retirement account. It's a good start, Zane.
I agree with that.
All right, your homework is on the board over there. Page 48 through 50, 3 through 54. Times 3 means multiples of 3. All right. Oh.